Hello and welcome back in the follow-up stream for the Houdini roulette. So this time around, I don't know if you remember, but the first time we actually ended up with a roulette that was driven by several parameters, but I suspected that it was absolutely possible to switch to only one parameter. And it was indeed the case, because I've looked up for the mathematical backbone for doing that, and I ended up finding it. So now I want to share it and build it so that we can have the roulette on only one slider. So let's go back in Houdini. So maybe you will notice that there have been some addition to the node tree. So this part, so I will go through the additions, and then we can dive in the setting up the one control roulette. So this part of the tree is only the side of the roulette, which I didn't add to the modelization on the previous attempt. I added bevels on most of the stuff that we had, so those little blockers have bevels now. Everything that I added, I put in white boxes so that it's easy for you to catch up. So I moved the poly extrude of the circles that will hold the photos of the characters that the roulette is picking up. I've put it before the copy to point so that it's more easy to add UVs, and also more easy to create groups, so that I can have the face of the extrusion in one group, and the rest in another. See, now we have a group for the face and a group for the rest, and this will allow us to down the line. So right now, after the copy to point, I split between the faces and the backs. So, and then I name the back as back, I guess, faces back. And I did a little wrangle to name the slice by slices. So now if we look at the geometry spreadsheet, we can see that our faces have names. This will make it easy for applying texture within Solaris down the line. And after that, I do a little bit of cleanup on the geometry and merge everything together. And now we have the same roulette as last time, only with UVs and bevels. That's it. All right. So, yes, last time, this was the state of the controller. So we had the slice picker, which is the number of slice we make out of the roulette, and that corresponds to the number of ChatGPT persona that we will add to the roulette. Right now I will be working with 6 because I think that 6 is a sweet spot, but yes, I wanted to keep the possibility to add some personas later, and that's why I went down this whole procedural roulette rabbit hole. And I had this distance from the center slider, so this drives a copy of the circle that allows us to So it's an offset copy of the same circle that is the roulette, with only the extremities, and we copy the points onto that circle, and the radius of this circle is driven by the uniform scale. And so sorry, I will be able to do it, I swear. So the distance from the center, since our big radius for the roulette is 1, big R is 1, we can just copy paste this parameter inside the uniform scale, and this gives us the distance on the roulette radius. So we have that distance, and it's a very important factor for it's the key factor. This distance that we will later call little d is the key parameter for driving the circle size. So right now it's its own parameter, but later it will be a function of the number of slices and this distance from center. And that is something that I could have done right the first time around, but I didn't realize that it was that easy. But I did some expression linking on the uniform scale of the circle that is holding the photos on the roulette, and it was not really the best way to do it, because actually it's super easy to drive the circle size with the distance on the radius, because the distance on the radius, so d plus the radius of this circle that holds the picture, we know that d plus small r, so the radius of the circle, d plus small r equals big R. And in that case, I only need to reference the distance from the center inside the radius of this circle and make 1, which is the big radius of the roulette, big R, minus this parameter. And in that case, it's always sizing the little radius correctly. So base relative reference, and now 1 minus this parameter. So now you'll notice that the circle will always be glued to the extreme limit of the roulette's side. So that's progress. But we also want to maximize the surface area of this circle. And for that, we need to do a little bit of trigonometry. So let's dive into Illustrator, where I set up a little walkthrough of the demonstration. So I did quite a bit of research myself. It's an easy demonstration, but I'm a little rusty when it comes to trigonometry and mathematics. So I took a lot of roads, and I was near the solution, but quite not at it. So I asked for a little help from ChatGPT, which it obviously did find the solution pretty easily. But yeah, I will show it to you as well. And after that, we will have a simple H-script expression. After that, we will have a simple H-script expression to input in that parameter, so that we can calculate the distance from the center. So yes, I told Illustrator, so we need to change scene and dive into Illustrator. So this is a representation of the slice. So O is the center, B an extremity, and A another extremity. Like we talked about earlier, big R, I don't want to learn more, thank you. Big R is the radius of the roulette, okay? So we have the angle alpha. We know that alpha is, because the whole circle is 2p radians, right? So this angle measurement is 2p divided by alpha. We know that. So we can write it down. Alpha equals 2p divided by x. Now I will draw the bisectrix of this angle, and we will draw the inscribed circle. So that we know that for the circle to be maxed out, it has to be tangent to this arc and also tangent to the border of the slice. It just makes sense. If it's bigger, it's not inscribed in the pie, and if it doesn't touch the sides, it's not the biggest possible. So we know that for sure that this 3 contact point circle is the biggest inscribed circle there is. So we will call the center of this circle C, and we will do some measurements. So this value is D, the distance from the center. It's the one we're looking for. And yes, it's the value we are after. It's very important. So we also can see that it's what I told you earlier. This distance is the radius of this small circle between. So the circle sits on C, the center, which is at D, and C, and sorry, so T plus little r equals big R. I realize that maybe you don't say it like that at all, but sorry, it will be like that for this session. I will look it up after. Big R, small r, little r. It's probably wrong. Maybe I can look it up quickly. Ask for ChatGPT. Ask ChatGPT quickly. So when doing geometry, I have a capital R and a little r. How do you refer to those markings in English? Because I keep saying big R and little r, and I suspect that that's not the correct way to pronounce it. They sound childlike. Indeed, they sound childlike. So capital R and lowercase r. Unfortunately for me, it's not that easy to pronounce to me, but we'll roll with that. Okay, so I will just need one quick second and I'll be back to you. All right, so let's go back to our math. So, like I said, D equals capital R minus lowercase r. Okay. Now, by construction, a tangent is perpendicular to the radius that touches the point. I don't know if I'm being clear, but if you see the schema, it will be clear, I suppose. So we know that this segment is also the small radius, and it's a square triangle. It forms a square triangle that has D as an hypotenuse and R as an opposite side. Okay, so that allows us to express D as this. From the trigonometric definition of sinus, we know that sinus of alpha divided by 2, so this angle, alpha divided by 2, equals the opposite side on over the hypotenuse. So we can further develop that. So it means that sinus of P divided by X equals R divided by D. So that means D equals R divided by sinus of P divided by X. And now that we have those two expressions, we can combine them to express little r as a function of we can express now that we have those two equations, we can express little sorry, I'm doing one more for the video. Now that we have those two expressions, we can express capital R. Now that we have those two expressions, we can express lowercase r as a function of the capital R. And it's only a matter of a little expressions. So at the end of the day, we have this expression that links lowercase r to capital R. Okay? And if we have lowercase r, we have the distance from the center. So, once we have that, how do we input everything back in Houdini? So the Houdini adaptation is pretty simple, but there is one little catch that we need to be aware of, is that, so this is the expression of D by R, okay? So in our case, we have make it simpler by choosing R equals 1, and we can simply swap R by 1, and we have this expression of D. So this is the expression we want to input in this parameter. That's pretty simple, right? Yeah, I don't know if it's simple. It's just pleasing to see that we can express everything with only one parameter. Anyways, so what we need now is to translate that to HScript, and it's actually not that complicated, but there is one catch, like I told you. So 1 minus the sin function, and we use the degree function because in HScript, sin expects the angle in degree, so we have to convert it, because right now we're expressing the angle in radians. So this is the only little thing that we need to be aware of, so that we have the correct results. And actually the rest is the exact same thing, just written down in HScript. So now we can grab that and paste it inside Houdini, and magic should happen. Oops. Oh. That's funny. I changed the multiplier, so it's it defaulted to 1. So we have now the exact number of slices for as sides to our setup, and that's not interesting, but that's not what we're after. So I will paste and we were at 12, and I will paste the expression in the correct slot. It will be much better. And now you can see it's happening. We have the roulette like we want it, always with the circle maxed out. Wait a sec. I want to see the front. Why don't I see the front? Set view, front viewport. That's weird. I don't understand this view. I don't understand why the front view is broken, but okay, it's not a big deal. Let's move on to the next topic. So now we know for sure that our circle will be the biggest possible, but what we would like is some padding, and I think we can use as padding something that is a function of d, so maybe 0.9d. So in that case, so we can remove that parameter or maybe repurpose it. Yes, we will repurpose it and call that not radius, but pad. Padded distance. Okay. So we'll copy that parameter, paste it right here, and multiply it by 0.9. So now we need to call this inside our radius, and also right here. So right here it's not dist, it will be pad. So you can already see that it's smaller, and we will need to input that. Okay, so we need an extra parameter. We'll call that extra parameter so it's a float. So you will be pad, sorry. You will be pad dist. Your pad. Okay. So it was a little too much, 0.9. So let's dial in 0.95. Your pad. Okay, that's better. So right now in here, it's no, in here, sorry. Ooh. In here it's indeed pad dist, so we're good. And now we can multiply. I did it because since the radius on this one is the complement of D, using pad dist would have made the radius even bigger. I think I can show it by just tweaking padding, and no, it doesn't move the... it's because it's not using padded distance right here. Anyway, it's something about the complement that would have been inverted. So now we can do that and multiply that by padding. No, it's not like that. Oh, sorry. Oh, yes. Okay, so this is unexpected. I thought that doing it like that would prevent exactly that from happening, and it's indeed not the case. So let's check. Maybe I should multiply 1 by that. Sorry. Still not good. I'd rather... Okay, so let me think 1 sec. So when we introduce our padding, what we are actually doing is saying that, oh, yeah, I should simply do the padding on the radius of the circle. So let's forget about modifying this and just apply padding to the radius. So to do that, we remove this parameter. Okay, I will handle it with the OD destroy parameter tool. Remove spare parameter. Okay. So now this is removed. So now we need to input this back onto that one. Okay. Now this one is broken too. Because but this doesn't exist anymore. All right. And now we can control the padding only on the radius, which is a way cleaner solution that we can do like I initially tried to do. So let's just find a value that looks correct. I think I like that. Yeah, it's good. Okay, so now we can move on to the, oops, sorry, I'm sweating a lot. This is not very elegant, but I don't care because nobody's watching. Yeah. Okay, so now we have our nice little roulette setup. So what we can do is go to Solaris. I'm looking for the grid. Ah, yes. So I have a recipe for a quick Solaris setup. I will call it. I don't remember what it's called, but I can look inside the recipe manager in Ops. Oh my god, where are my recipes? Ah, here. Okay, basic Solaris portraits. Ah, it's okay, it will be portrait, but it's not a big deal. So this camera, let's move everything on the grid. This camera we will transform and make it, oh, it's already 16:9 aspect ratio. So let's import our geometry. So what I like to do is import it with force objects. Because that way the display flag don't matter. I'm mixing up my, yes, okay, so shot one. Okay, so let's move the camera back. We'll probably need a slight angle to make it look a little better. All right. So now the materials. So we will need, I will just add one face to the roulette at the moment, and we will build some pretty basic and standard materials. Roulettes are often metallic, so we will use metal shader for the border and the stops, and yeah, let's start with that. We'll make it silver. I don't remember exactly what the IOR for silver is, so let's quickly check it on 0.18. Okay. So we will need some kind of plastic white for the back of the faces. So something pretty glossy. We'll build a placeholder for the faces. And we will need so I will make it a placeholder for now, but I would like to have, we'll just ask for the geometry. So this will be the wheel. Add that to the base color. All right. Okay, so now we have our materials. We can assign those on the geometry. So you see why I did name the primitives inside subs? Because now, even if I have one, only one, sorry, I have all my geometry within the roulette, but since it's named correctly, I can easily apply materials with the material linker. So I want the silver to be on the picot, on the border. I want the wheel to, oh, so I have, yeah, okay. I have I have each slice named properly, so I could probably do that some other way, but for now, let's do that. Faces go on faces. Actually, I did it wrong. Faces, I can do that. It's easier. And the same for the slices. And I can get rid of everything else. So it's cleaner that way. Okay, so let's go back to the scene view. So we can see that something is assigned. Okay, it's ugly, but it's what we expected. Yeah. So we will need to add some proper lighting on top of that. So what is this light? I have no idea, but it's already a little better, except it's incredibly pink. Okay, so I have this plugin that is, except it's not here. The asset library. So this one is probably good enough for this scene. Yeah, it's okay. So we can see that even if we divided the geometry quite a lot, it's still a little, you can feel the edges, so I will divide it a little more. Okay. Yes, it's better. Okay, so those colors are pretty ugly. And those colors were actually obtained with the random color we assigned, but I think I would rather have colors that are... Yes, I want 3 colors, and I want the colors to be... So if I take 3 colors, no matter how many slices I have, I will always get the possibility for a slice to be surrounded by 2 slices that do not share the same color. So we will use Modular to create that effect. So we will go back to our Rango and change it. So what is it we want to do? Sorry. Yeah. We want to divide slice by 3. Okay, so we can remove everything. Delete all spare parameters. Where is it? There it is. So what we want to do is divide slices by 3. I don't remember exactly how it's done. I don't remember if it's a float or no, it must be a float. Color ID equals at slices modulo 3. I will check it as an attribute. It's not slices, it's slice. Yes, okay, so it's not a float, it's an integer. And now we can simply assign our colors to this color ID. So if so we don't need to write it, so I can just call it int color ID if color ID equals equals 0 at cd equals call 1. I think you can input color that way, but yeah, it looks like it's working. Okay, so now we can do that twice again, except we will increment every section. So I won't be dialing colors because I think I will need to find my palette, but right now it's pretty okay. Meaning that so why are you unhappy? I think it must be genre a cast something error. Yeah, implicit cast from float to integer. I think it can be fixed by doing that. Ooh. Oh my god, I'm so bad with the keyboard. This is a little embarrassing, but I fixed it. Okay, so So now we can resume our shading because it's already better. I will keep it super basic because I don't know, I don't need something super fancy. And actually, let's just check that everything is okay. So 1, 2, 3, 4, 5, 6. Yes! This is so satisfying. Oh, this is unexpected. I thought that I would avoid this configuration completely, but it looks like I might have had the wrong idea. So could it be Okay, so I guess that after every multiple of 3, you get this configuration. Yes, it's the case. Maybe I can have a wildcard as my primitive number 0. That should prevent the case. It's not very elegant, but I won't have the issue at least. So I suppose I could do that. No, it creates another issue. Okay, using call 3 seems to do the trick, but is it bulletproof? I'm not 100% sure. I think it might be, but let's check with 10. No, it's not bulletproof. I should use the modulo twice, maybe. Interesting. I'm sure there is a super simple solution to that problem, but I haven't think of it. I didn't thought of it, so I'm brainstorming live, and this is a bit sketchy. So let's just do the wildcard, okay? And if I come up with a more elegant solution, I don't think I will go back to that setup inside the video just for that. But what I will do is once I have a website, if I do a little blog post on this setup, I will add it later on in the blog post. We're far from it because I have a lot of stuff to do for this channel, but this is something that I will keep in mind, especially since that it's been recorded live, so it's on the internet. That should be a pretty good reminder for me. So yeah, the wildcard. Let's do the wildcard. It's color 0, color wildcard. And add that. And where are you? Oh god, is it ugly? Okay, that's better. All right, so now this problem should no longer exist. Indeed, it doesn't. All right. Okay, so now what we can do is quickly adding Grandma Lilith in the mix and making a question card for every other photo there is. And for that, we will dive into Photoshop quickly. I will take a quick break during the launch of Photoshop. Okay, so here in Photoshop I laid out a square artboard. Now I can just do one question mark for the tile where the persona is still unknown. Make it white. I don't need it to be in bold italic. Bold is enough. And let's make it bigger even. Okay, so this is our first texture. I'll save it as a PNG. Now we will import Grandma Lilith head. So where did I put her? I forgot where I stored my trusty Grandma Lilith. Ah. Okay, so I have Mortimer, but I can't seem to find Grandma Lilith. Where are you? Ah, there she is. Okay, so I need the head only version. Okay. Let's make her a little bigger. Okay, that's enough. And save that. Okay, so the edges are not that clean actually, so I will just add a quick inner glow, make it darken black, and tweak it so that it's I don't understand why this is still super smooth. Okay, I think that's enough. It's still better than the first try. Okay, so now let's save the roulette question mark document. Save that as roulette Lilith. Okay. Now back in Houdini, Let's go to the stage context, go to the material, faces. So we will first input the question mark. So this is an image. I think the tile image is more easy to handle than the other, but I might be wrong. Oh, I don't think I saved the files at the correct location. Yeah, no, it's not in the correct location, so let's save it again. And now the question mark. Okay, so back in Houdini, we have to refresh that. So I will first rotate the UVs. And then move them a little bit until we have it centered. Scale everything down a little bit. Hey. Okay, something wrong is happening. I don't know what. I no longer have control over my parameters. That's weird. Okay, so maybe Houdini has frozen. I don't know. Let's just save it. Okay, at least I can save. So that's one thing. Maybe everything's back. No, it's not. So we saved. I can safely close it and launch it once again. Every time I close Photoshop Beta, I get this message that it crashed or an error occurred, but it's not the case. I simply closed the software, so don't send. So now let's reopen our project. So we are transforming the UVs. Okay, so the controls are back. Okay, so the shader is so reflective that, no, it's not the shader, we are in Vulkan. Let's go back to Karma. Okay, so now we can see that our question mark is indeed there, but it's not correctly placed. So I will keep moving the UVs around. I know that's not the best way to do that, but that's the way I will do it on that video. Okay, and now you. Okay, so it should be a little smaller again. Oh, forgot to dial the all dimensions at once. Okay, so this is better, I think. Okay, displacement seems fine. Now we will add Grandma Lilith to the mix. So we will duplicate this material faces. So those are question mark. You will be Lilith. So this one we will call the Lilith asset and move back to the material linker. So the rules, let's check out the rules. Hey, where is it? Okay, so we want questions. Okay, and now we will just link Lilith to one of the faces. So face 0, I guess. Let's choose this one. Yeah, we have Lilith. She's there. Awesome. Except that the placement is not great, but I don't think it's very interesting to see me tweak the placement, so I will keep it that way for at the moment. Maybe we will just dial some parameters a little bit, like I don't think that the roulette material should be very reflective. So the wheel, what's the value there? Yeah, it could be rougher, so maybe 0.3. What else? I think the rest boils down probably to modelization. No, I could do a lot more of lighting and shading, but I think that's enough for a YouTube thumbnail. So let's just frame it. Oh, so now that we are on the Karma render node, we have an incorrect aspect ratio because I dialed it that way in my recipe. So now this is okay. I think we can add a little bit of extrusion on the circles, so maybe double it, maybe even more. Oh, it did change the UVs, so let's not mess with the UVs and just place grammar correctly. I said I wasn't doing it, but you cannot trust me. I change my mind constantly. That's better. Maybe we can check if just a little more light. Maybe we can add a studio, what's the name? A metallic, special metallic. A packaging HDRI. Yeah, something like that. Mm. I don't think that's very interesting. Sorry. We'll keep it like that for now. What if the wheel was... Okay, so I will stop right there. Just quickly play a little more with the... Yeah, that's the... I did it the wrong way because now the UVs are not following the geometry correctly unless in some fringe cases. But yeah, that's it. So if I when I correct this, I will add it to the IP file, and and I will try to fix it later. This end of stream is catastrophic. I'm sorry about that, but yeah, I think I just need to call it a day, because for the most part I did what I wanted, so I'm quite happy about the result. And yeah, that's it for this video, and see you next time. Ciao.